Hello, everyone. Thank you for coming on a Thursday afternoon to Mandalay Bay. My name is Sumit Thakur. I'm a Senior Manager of Product Management for Amazon SageMaker at AWS. And today I have with me my colleague, Giuseppe Porcelli, who is a Principal ML Solutions Architect at AWS, and Mark Neumann, who is a Product Owner for the Machine Learning and AI Platform at BMW Group. And together, we are going to talk about how to scale your machine learning development using SageMaker Studio. Thank you, gentlemen. Okay. So before I begin talking about how to use SageMaker Studio to scale your machine learning development, I want to do just a quick recap. So SageMaker Studio was launched at re:Invent back in 2019. And it was launched as the first fully integrated development environment for machine learning. It brought together everything that you need for ML into one single unified visual interface, which means you have purpose-built tools for every step of the machine learning workflow accessible within the same visual interface. So tools like data labeling, feature engineering, building models using code editors, and then for tuning, deploying, and managing the end-to-end machine learning workflow, you can find the tools for every step in the same visual interface. This also means you can quickly move back and forth between these steps, make changes, observe the outcomes, and iterate fast to quickly roll out your new machine learning capabilities in your organization. And today, tens and thousands of customers are using SageMaker Studio, which gives us a highly privileged opportunity to work with these customers to understand the trends that impact the machine learning developer experience. And I'm going to discuss some of these trends. So one of the first trends I want to talk about is just the increasing pace of AI adoption. One of the key indicators of AI becoming pervasive in our economy is just the growth in AI investments. The AI Index report, published by Stanford University early this year, estimates that the global corporate investments in AI grew by a staggering 13 times over the last decade. And the trend is not stopping. It's going to accelerate further because of generative AI. What it means for developer experience, that developers are asking for tools which are highly performant and makes them more productive in quickly getting from data to model to insights. The next trend I want to talk about is the proliferation in data and AI-specific job roles and specializations. Given that machine learning is so complex, it's highly unlikely that one person possesses all the skill sets needed to develop and deploy a model. For example, a data engineer might specialize in pulling together data from multiple different sources, integrating them together, and then transforming them into a form and shape which is useful for analytics and machine learning. While a data scientist may specialize in doing feature engineering on top of this data, and then choosing algorithms to build and experiment with models. And then a machine learning engineer might have the skill sets to take this model, deploy it into production, and automate the process of deployment and retraining the models at a cadence. Given this rapid proliferation in AI-related roles, more and more machine learning developers are asking for tools which are purpose-built for their specific task. And the third trend I want to talk about is the continued impediment in taking your machine learning models from prototyping to production. So a Gartner survey estimates that only a little over 50% of the models go from prototyping to production. Now the tools, the skill sets, and the processes for building a model are substantially different from that of deploying the model. And developers are asking for tools which are more self-serve, so the model builders can quickly take their prototypes into production. To make it easier for all of us, I'm going to summarize these key trends in the form of 4 Ps. The first two is performance and productivity. As I said, to keep up with the pace of AI adoption, developers need tools which are highly performant and make them productive by removing any undifferentiated heavy lifting out of the way. The next P is preference. Given the proliferation of data-related roles, developers need tools which are purpose-built for their specific tasks. And finally, productionization. Model builders need more self-serve tools to take their prototypes into production. And in order to address all these 4 Ps, the 4 key pillars of the developer experience, I'm super pleased to announce the launch of next generation of SageMaker Studio that comes with a blazing fast startup experience, an even broader selection of the code editors, AI-based assistance for all your ML tasks, and new tools to automatically convert your machine learning code into pipelines. Some of these tools were launched in our leadership keynotes over the last 2 days, with the latest one being the code editor, which was launched in Vernal Vogel's keynote this morning. We are going to do a deep dive on each of these innovations one by one. First, let's talk about the performance, on how the new blazing fast startup of Studio meets the performance standards of a modern-day machine learning developer. We have done a couple of things to improve the startup experience. So first of all, the initial setup of Studio has been significantly simplified, which means in one single click, you can now set up a SageMaker Studio domain with IAM-based identity and access management, fully managed connectivity to public internet, and underlying compute and storage for building your machine learning models. Setting up Studio is now literally as simple as flipping a switch to turn on a smartphone. Now, once you have set up the Studio, you can launch Studio with a simple click, and it loads up the application in your browser in less than 5 seconds, giving you instant access to all the tools in your browser. Now, one of the first things you might want to do is to start writing code, and for which you want to spin up a code editor. So what you do is you go and you create a SageMaker space. A SageMaker space is like a workspace in cloud that stores your compute, storage, and runtime preferences for your development environment. The space comes with many capabilities. For example, you can stop a space, come back to it later, restart it again, and resume your work from where you left off. All your work is automatically saved on the underlying EBS storage. You can also scale up and scale down the compute and the storage of the space with a simple click. So for example, you could start space on a lightweight CPU instance when you are doing data exploration, and then immediately flip to a beefier GPU instance as you begin your model training. The space also comes with several capabilities to share and collaborate artifacts with your team members. So you can attach a shared file system like Amazon EFS onto a space to share your code, datasets, and artifacts with your team. You can even create a shared space in which you and your peers can come together and review and co-edit the files in real time. Once you have the space set up, you can launch an IDE, such as Jupyter Lab or RStudio, from the space. The Jupyter Lab loads up in your browser in a couple of seconds, and it comes pre-configured with SageMaker Distribution. SageMaker Distribution is a data science and machine learning runtime, which comes pre-configured with several popular data science and machine learning packages, so you can quickly get started with writing your machine learning code. And we are going to give you a demo of this entire experience. But however, I'll show you a couple of slides about how the visual experience looks like. So this is the homepage of the new SageMaker Studio. You can see on your top left, there's an applications gallery from where you can pick up a code editor of your choice. Let's say you pick up Jupyter Lab. It immediately opens the modal in the center of the screen to help you create a Jupyter Lab space. All you need to do is to select the compute for your space, storage for your space, and the runtime. And you can see defaults for each one of them, where the default for runtime is the SageMaker distribution. Once you have made these choices or reviewed these choices, you can quickly launch the space and get started with writing your code. You can run multiple such spaces in parallel, each with a different combination of compute, storage, and runtimes, if you're working on multiple different projects or multiple different experiments at the same time. You can come back to this page, review all your running spaces, terminate a space, stop a space, resume a space. You can do all of that from this one central place. And as I said, we'll walk you through the demo of this experience very soon. Let's talk about the next P, preference, where developers are asking for their preferred tools for their specific tasks. As you saw, SageMaker Space comes with support for both Jupyter Lab and RStudio. But our customers have been telling us they need more choice. They need IDEs with much more robust support for debugging, refactoring, and deployment tools. And one of the IDEs they have been asking us for is VS Code. So I'm super excited to announce the launch of new code editor in SageMaker Studio built on top of the Visual Studio Code open source. This is built by AWS, and it uses the Visual Studio Code open source core, which means all your familiar VS Code shortcuts, terminals, and debugging and refactoring tools work in code editor. It also comes pre-installed with an extensions marketplace powered by OpenVSX from Eclipse Foundations, which gives you access to more than 3,000 VS Code compatible extensions. And one of the popular extensions pre-installed in code editor is AWS Toolkit. That gives you an easy access to many of the AWS services like Lambda, S3, Redshift, Code Whisperer, so you can quickly get started with building and deploying applications on AWS. And finally, similar to Jupyter Lab, the VS Code runs on a SageMaker space, so you get all the benefits of the space. You can attach a shared file system. You can resize compute and storage on the fly. It comes pre-configured with SageMaker distribution, so you can quickly get started with writing code. Now, with the broader choice of IDEs available within SageMaker Studio, your machine learning workers can come in and pick and choose a tool of their choice for the task at hand. As an example, a data scientist might come in and pick up Jupyter Lab IDE from the app gallery, an experiment tracking tool from the tool gallery, and then begin building and experimenting with models. While a machine learning engineer might come in and pick up the VS Code IDE from the app gallery and a pipelines tool from the tool gallery to start deploying and automating model pipelines. Next, I'm going to talk about the third P, productivity, where developers are asking for more efficient ways to get from data to insights. The new SageMaker Studio comes built in with generative AI-based assistance for all your ML tasks. Your editors like Jupyter Lab and VS Code both come pre-installed with automated code generation powered by Code Whisperer, which means you can now generate Python and data science code by simply adding a comment in your IDE in plain natural language. You no more have to go about spending hours in looking up code samples from the internet, debugging those samples, remember API syntax. You can just get started coding in the IDE. In our internal studies, developers who use Code Whisperer were found to be 57% more productive than the ones who didn't. The IDEs also come built in with an AI-based chat companion. So you can have a natural language conversation with the chat companion to do tasks beyond code generation. So you can ask for advice, for example, to explain a code sample, to debug an error, or to even ask recommendations to refactor your code. The chat companion is very powerful and highly customizable. You can pick and choose the foundation model that runs and powers the chat companion. So for example, you could choose to run Claude V2 model developed by Anthropic, available on Amazon Bedrock, or you can choose to run StarCoder developed by Hugging Face, available on SageMaker Jumpstart Model Hub. The Jumpstart Model Hub comes with now more than 150 open source models for multiple different tasks. And all of those models can easily be deployed from Jumpstart interface onto SageMaker endpoints, and from there, they can be used to power the chat interface. So you can play with those models right in your IDE. It's a pretty fun experience, so I would definitely encourage everyone to give it a shot to try out different models in the IDE itself. Next, I'm going to talk about the final P, productionization, on how to build tools which enable model builders to self-serve, get their prototypes into production. Here, we have done a couple of innovations. We have significantly changed the SageMaker Python SDK. We have introduced a new set of decorators in Python SDK, using which you can annotate your Python code and automatically run that code as a job on SageMaker. The decorators automatically determine the runtime needed to run the code as a job based on a requirements file or a YAML file that you provide at runtime. What this means for you is you can take a code that you have written on your laptop and have been debugging for a while, and you are satisfied with the code, and quickly scale it out to a beefier instance on cloud without making any code changes, just by adding decorators. And this works not just for one Python function. If you have multiple Python functions in your code, where each function is designed for a specific task, you can stitch them together into a pipeline on SageMaker. All you need to do is to annotate those functions with the step decorator in Python SDK. If you're a notebook developer and want to run your notebook as a job, it's even simpler in SageMaker Studio. You go to SageMaker Studio, choose the notebook, and you can create a schedule for running this notebook as a job. And SageMaker automatically triggers the job, determines the dependencies which were used in authoring the notebook, and then uses it to create a container and run this notebook as a job on SageMaker, and pushes all the outputs of the job back into SageMaker Studio for you to review and monitor. You can even orchestrate multiple such notebooks in the form of a pipeline. You can actually create a DAG of many of these running notebooks. So for example, you might have a notebook which takes in data from S3, performs some feature engineering, another notebook which takes these features and performs a hyperparameter tuning, while another notebook which takes model candidates and do model evaluation and generate evaluation reports. You can stitch them together into a pipeline using the new SageMaker Python SDK. And finally, we have dramatically simplified the model deployment process. Now, you can deploy a model onto SageMaker in just 2 simple steps. The new model builder class in SageMaker Python SDK allows you to pick up a model artifact and call out a function model.build, where SageMaker automatically determines all the ingredients for deploying this model onto an endpoint, which includes determining what inference server to use. Could be a Triton server, could be a Tosser server, depending on the type of model artifact. It determines what would be the appropriate compute for running this model. It also automatically generates the code scripts, which acts as a glue in parsing the incoming inference requests into a form that is suitable for consumption into the model, and packages the response generated by the model into a REST API output. And then SageMaker takes all these ingredients and deploys them onto an endpoint, which is high throughput, low latency, and a fault-tolerant endpoint. Now to give you a demo of all of these awesome capabilities, I'm going to invite Giuseppe back on the stage to help us with a live demo.
Thank you. Thanks, Sumit.
Thanks, man.
So before we get into the demo, let me spend a couple of words on the use case that we are trying to solve today. So we want to solve a pretty simple problem, which is detect failures in machinery with machine learning. Well, it's a hard problem, but it's simple based on the data that we're going to work with today. We are going to choose the AI4I predictive maintenance dataset from the University of California, Irvine machine learning repository, which is made of a few features that you can see here on the slide, like the type of machinery, the temperature, the rotation, the rotational speed, the process temperature. And well, the variable that we want to predict is the machine failure variable, which is a binary variable. So as you can imagine, we want to train a binary classification model here to try to address this use case. And what we're going to do is use SageMaker Studio to build, train, deploy the machine learning model, plus we will use Amazon SageMaker pipelines to orchestrate the end-to-end, the entire machine learning workflow. Great, let me move to the demo. As Sumit mentioned, we have extremely simplified the onboarding experience to SageMaker Studio, and you can literally onboard to Studio in one click. Sorry. If you click on this button here, set up for single user, what will happen is that the SageMaker Studio domain will be configured automatically for you with a single user profile being created with a set of default configurations with an Amazon SageMaker Full Access execution role, with default networking configurations and so on, and you can soon get started with this domain. Otherwise, if you want to set up Studio for organizations, we have also simplified that process with a wizard-based user interface that allows you to customize how SageMaker Studio has to be configured in your organization. Great. For this example, we already have a pre-created domain, which is this one. Let me get into the domain and then open SageMaker Studio for this specific user. Great, we are now in the new SageMaker Studio user interface. As you can see, we have the application gallery on top left, the left navigation, and the landing page here, the main screen here, where you can choose whether you want to work with Jupyter Lab, or Code Editor, and you also have the getting started set of resources accessible. Since we want to train this binary classification model, we want to solve this problem, as a data scientist, the first thing that I want to do is use Jupyter Lab to explore my data, to pre-process my data, to then build a machine learning model. So I'm going to create a Jupyter Lab space here. Let's give it a name. And the space will be ready in a second, and we will be able to customize the configuration, as Sumit mentioned. So we can configure the storage that we want to allocate to this specific space. We can choose to add lifecycle configurations to customize the way the environment is configured through shell scripts which are executed at the bootstrap of the instance, of the underlying instance. We can attach a custom EFS file system, as well as we can choose a variety of compute resources, including CPU and GPU instances, as well as fast launch instances which will run in less than a minute. So let's select one instance, for example, and we use as the image, as the runtime image, the SageMaker distribution here, which is set by default. Now let me run this space, and I want to spend a couple of words more on the SageMaker distribution. Back in May, we launched the JupyterCon, the SageMaker distribution project. This is an open source project. What we have done is we have put together in a single distribution the most common frameworks and libraries for machine learning. We make sure we have built this as a conned environment. We make sure that the dependencies and the versions are correct, let's say, in this conned environment. And also, we have delivered the distribution in the form of a Docker container. So you can go to GitHub, even pull this Docker container, even try using the SageMaker distribution locally. The SageMaker distribution powers both the Jupyter Lab applications and the code editor spaces in SageMaker Studio. So this is pretty important because we can move from one environment to the other using the same runtime, so keeping the runtime consistent without having to make sure that we customize the runtime when we move from one place to the other. Great, as you can see, in less than a minute we have our space ready, but I have already a space with all the code that we need pre-created. Let me open Jupyter Lab here. So Jupyter Lab loads, as I said, this is a repo that I've cloned for this particular example. Let me get into the first notebook. As a data scientist, as I said, I want to make sure that I can explore this data, pre-process this data, then fit a model, train a model. As I mentioned, the SageMaker distribution already contains the most popular frameworks and libraries. So here, I want to work with Pandas, XGBoost, and scikit-learn. What we're going to do is we're going to use scikit-learn and Pandas to transform the data, to do the data exploration and preprocessing. Then we are going to use XGBoost to create the deep binary classification model. You can definitely customize the runtime environment installing additional libraries as you would do. And in this case, we are installing a visualization library, which is Seaborn. Then we download here the dataset from the University of California, Irvine ML repository, and we start with some exploratory data analysis. I mean, we can run some of these cells here. What you can see here, we are just taking a look at the dataset, then describing it, then checking the value counts for the machine failure, so how many positive versus negative examples we have in this dataset. Then we are plotting this information, standard plotting operations. Then at some point, what I want to show is, hey, I want to compute the unique count of values for columns in this data frame, and maybe I don't remember the API that I need to call. And what we can use is Amazon Code Whisperer, which is running on the Jupyter Lab now, which is providing us the suggestion for this function. Another thing is, I want a function that removes a column from a data frame. Okay, so here we see the Code Whisperer suggestion. I can accept these suggestions, and I have my function ready. So it's pretty powerful tooling that can help us developing within the notebook itself. Great, let's move on. Here, what we're doing is we are removing some columns that we don't need for this specific problem. We don't want to include. Then we are plotting some the variables to check potential, to spot potential correlations using Seaborn here, a pair plot. And then we get into the data preparation code, the data preprocessing code. So this code is defined as a standard Python function, as you would expect, which is called preprocess, which takes as input our data frame with all the data, and does a few operations like doing training, validation, and test splitting. Then it applies some transformations using scikit-learn. Specifically, we are scaling numerical attributes, and we are one-hot encoding the categorical ones to then, fit the model later on. And then this function returns, as you can see, the transformed data, so the preprocessed data, plus the model itself, this featureizer model made with scikit-learn, which is able to transform our data. So I can run this function, and we have our new model, the featureizer model here. This is the representation of this model. And we can look at the data that has been transformed. Standard preprocessing operations here. Then we move into the model training. Here again, I have a train function, which takes as input the preprocessed data, so the training and validation data, plus a few hyperparameters for the XGBoost algorithm, and then it fits the XGBoost model. That's what it's doing here. We are training here the model, the XGBoost model. The return of this function, the return value of this function is the XGBoost model. Great, we execute the function, we are fitting. We are also computing some metrics like the accuracy, precision, and recall, which are pretty convenient when we are working in with a binary classification problem. Great. Now, last thing that you would do as a data scientist maybe is using these two models to run some inference on the test data set, which is what we're doing here in this function. Great. Now, let's say we are satisfied for what we have done here in the notebook, and we want to scale this code on different compute infrastructure. Why would I want to do that? There could be multiple reasons. It's because maybe my data set size increases and I want to use a larger instance or a set of instances to train my machine learning model, or maybe because I want to automate the execution of my code. So I am in a notebook, but I have to make sure that my code can also run as part of a pipeline, for example. Great. How we can do this? There are at least a couple of options here. One option is use the integrated notebook scheduling functionality, which is available in the Jupyter Lab environment. So what you can do here is, hey, I want to schedule the execution of this full notebook either now or on a schedule. So either I execute it on demand or on a schedule. And this runs in the form of a SageMaker job. So it will run on SageMaker infrastructure. Great. The other option, which we're going to show you here, is the remote decorator that Sumit mentioned. So what you can do is just with one line of code, we are importing here the decorator and decorating the function, the Python function. What we do is we run this code, and then exactly the same function that you're running here in the notebook is executed as a SageMaker training job on separate infrastructure. So what the decorator is doing is taking this function, is understanding the configuration of your runtime environment, and then executing this function as a SageMaker training job. If I want to monitor the execution of the job, I can go back to SageMaker Studio. I can go to the job screens, look at the training jobs here, and as you can see, there is one job that is executing, which is this pre-processing job. See, the pre-processing code is now running as a separate job on separate infrastructure via SageMaker training. Great. You can look at the information of these jobs, like the input artifacts and some other configurations, as well as what I want to show you is that the runtime environment here has been picked automatically. So this is the SageMaker distribution, again, that has been used as the Docker container to run our training job. So the runtime environment consistency here is on both the Jupyter Lab environment, the code editor environment, we will see shortly, as well as the jobs. So when you move to the jobs, keeping the environment consistent allows you to reduce the amount of work that you have to do in terms of configuring this runtime. Great. Our jobs are running. We don't have to wait for the execution. Now, what I want to do is, let's say that I have executed my two jobs, one for data preprocessing, the other one is for the actual training of the model. And I have my two models, the featureizer model and the actual XGBoost model that does the classification. What I want to do now is I want to work with an ML engineer to deploy this model to a real-time endpoint. What can I do is I can go back to SageMaker Studio and go open code editor now. So I'm not going to create a space in this demo. It's the same procedure that we have seen for the Jupyter Lab. We just open code editor that is already running in my environment, and we will see the code editor environment loading here. So, great. Let me open, well, I can do it from here. Let me open the specific folder that I have on my user home directory with this repo, again, cloned, and we move to the deployment module. Great. I have defined deployment as a standard Python script. The deployment procedure at high level consists of the following steps. We load the two models to memory, the featureizer model and the XGBoost model. Then we create two SageMaker models. So a SageMaker model represents some extra metadata that you need to deploy the model to a real-time endpoint. To build this SageMaker model, we will use now the new model builder class that has been introduced by Sumit. Then what we do is after we build the two SageMaker models, we combine the two models in what is called the serial inference pipeline in SageMaker, which is just one of the ways to deploy machine learning models to real-time endpoints in SageMaker. Why I want to do that? Because I want to make sure that the inputs that I will provide to the first model will be just the raw data that come maybe from the field. Then this model will transform the data and then pass to XGBoost model for the actual inference. And finally, we deploy the model. What I want to focus on specifically is how a model is built. So let's look at the new model builder class. The model builder class takes as input the actual XGBoost model. Then we tell a few other parameters like the requirements that are required for inference. And the most important thing, we pass the schema builder. The schema builder defines through an example input and output. Through the schema builder, we are able to automatically compute the marshalling functions for your model, so how data has to be serialized and deserialized. At the same time, you can customize this through extra classes. In this case, I'm using the request translator because I also wanted to further customize the way the inputs are provided to my model. You might be asking, hey, what happens if I want to customize the way the actual inference happens? I've done this for the scikit-learn model, where by inheriting the inference spec class, you can also customize the way the actual inference works through the model builder. Why? Because for the scikit-learn model, I didn't want to call the predict method. I wanted to call the transform method to transform our data. Great. That said, what we can do is we can open a new terminal. We go to the deploy folder, and we do Python deploy.py. What's happening here is the model builder class is packaging our models, is understanding automatically the configuration of the container images that we need to use for inference, is setting the appropriate configurations for the serving stacks, the underlying serving stacks, and is now deploying the machine learning models. So there is an endpoint, indeed, that we are creating, which is called SageMaker BTD endpoint plus a suffix. How can we verify this? We move back to the SageMaker Studio UI, we go to the endpoints section, and we see that there is an endpoint running here that is being created, creating state. So this is the endpoint that we are building right now. Great. At the same time, if we want to test some inference, I'm taking an endpoint that is already up and running. What we can do -run inference, which is an extra argument that I have provided to this script, to execute some inferences and see the results for a positive and negative example for our predictive maintenance problem. So based on the attributes, I believe it's the rotational speed, which is influencing mostly here, we are getting a positive and negative result here. Great. So we have seen how to do data exploration, pre-process data, build the model. Then we have done a model deployment step. Now we want to put all together, stitch all together in a SageMaker pipeline. So how can we do this using the new the new step decorator that has been introduced by Sumit? Let me move to the workflow here and open the pipeline. But before going into the pipeline details, how the pipeline is defined, I just want to show you the steps that we're going to create. So the first step is, as I said, the pre-processing step. As you can realize, this is exactly the same code, exactly the same pre-processing code that we were running in the notebook. It's the same function that I have moved in a Python script. Then we have the train function. Train function, again, it's the same function that we were running in the notebook, moved in a Python script. No specific SDK code to be written here to define the step itself. Then I have an evaluation function, which is very similar to the test function that we had in the notebook, but we are also returning an evaluation report from this function because after we train these two models, before deploying, we want to store the models in the SageMaker model registry, and we want to attach an evaluation report so that I can then access the model registry, look at the specific version, and check the performance of my model. Finally, we have the register model step. This step consists of, first of all, we want to create the two models, scikit-learn SageMaker model and XGBoost SageMaker model. These are the same functions that we used for deployment. It's the same code. And then we put together these two models here as a pipeline model, and we register the model in the SageMaker model registry, attaching the evaluation report, which is here. Last step in the pipeline is about the deployment. This is very simple. What this is doing is taking the model from the model registry and deploying to a SageMaker endpoint. How do we put all these steps together now? How do we stitch it together? We have to take a look at this function which create the steps. What we do is we are using the step decorator. A decorator is a Python function. Here we are not using the decorator with the annotation, let's say syntax, but we're using the decorator as a function. And the reason is that we are implementing a modular code. We are engineering our code, so we are implementing more modularity here. We are passing the various functions that we have seen so far, preprocess, train, test, register, deploy, to the decorator. Plus, we are making sure that the outputs of the previous step are passed to the subsequent steps accordingly, so with standard Python code. And finally, what we do, it's a standard SageMaker pipelines code. We create a pipeline, we pass the steps to the pipeline, and we define a few parameters like eta, max depth, and deploy model, which is a Boolean variable to decide whether we want to deploy the model or not. And then we upsert the pipeline, we insert the pipeline definition in the system, and we start the execution of the pipeline. Great, let's see how this works. So what the decorator is allowing us to do now is to convert the Python functions that we have seen into SageMaker pipeline step automatically without worrying too much about writing extra SDK code. We are now adding the pipeline into the system and starting its execution. And if we go back to SageMaker Studio, what we can do is look at the pipeline screens. This is my pipeline. We have one which is in executing state, which we started right now. Then we can take a look at the graph of this pipeline, which is indeed a preprocess, train, evaluation, model registration in the model registry, and finally, deployment of our model. If we take the specific execution, we can see where it is. Now it's in the preprocessing stage. And we can also take a look at the parameters that were used to execute this pipeline, plus additional information and additional metadata related to the specific execution. Last thing that I wanted to show you is about the SageMaker model registry. So one of the steps of the pipeline would register a new model version in SageMaker model registry so that we can decide whether we want to promote this model to production by comparing this version maybe with the previous versions of the model. We open the so-called model package group, which lists all the versions of the models that I have produced so far. We take, for example, this version 10 here, and here you can see the evaluation report that I had attached to the model in the model registry, so with the metrics, the accuracy metrics for the XGBoost model, as well as you can look, for example, at how this model has been would be deployed for real-time inference. So all the information about containers, environment variables, how the serving stack has to be configured have been applied automatically through the model builder class. So great, this concludes my demo. And I'm very happy to invite here on the stage Mark Neumann from BMW Group, who will tell us how BMW is scaling machine learning development using Amazon SageMaker Studio.
Thank you, Giuseppe. Did you know that BMW Group is a multi-brand automotive, actually? Of course, we are known for BMW cars and motorcycles, but there are also other brands. There's like Uplifting Lives with like our mini brands, and the Rolls-Royce luxury automobiles for BMW Group as well. And did you know that in North America, BMW Group is actually the largest automotive exporter? So there's a plant in South Carolina. I'm going to be there next week. And they're producing there the SUVs, the X-Series vehicle models, and distributing them worldwide. Of course, a large proportion has been sold in the US, right? But they're distributing this worldwide. So at BMW Group, my team is responsible for building and providing the AI and machine learning platform services. And we're working a lot with different business segments to help them build the actual AI solutions. And for example, there's one team, we work really close with them. They're responsible for the automated quality inspections in our worldwide plants, so as well in Spartanburg. And what they managed over the last years, they ramped up a global solution that achieves this high quality that we need, these high quality inspections in the plants. And what they actually do is they equip the production lines with sensors like video cameras, acoustic recordings, other sensor measurements. They do those recordings and they use AI models basically to evaluate. So what you can see with the picture right there is a camera pointing towards the production line. And every vehicle that's passing, an image is taken. And in this case, it's about presence detection. So this AI model that is getting the image is checking for the part that is highlighted in green, whether it's there or not. There are other use cases, checking for the right part that's been used, checking for any anomalies, right, or checking for distances between those parts. And why is it relevant, right? Because they doubled the number of models over the last years each year. And now they have hundreds of models in the production lines that need to be trained and developed. And when there are any changes, for example, regarding lighting in the plants or the production setup changes, they need to retrain those models. It's quite some effort. And for this, they need a capable environment to do so. They would like to focus on their model development and not on setting up the environments. And that's where we come into play. And for use cases like them and the growth that we have at the company, we needed to redefine our approach. And that's the story I wanted to share with you today, how we did that. But to understand, that's not the only segment where we benefit from AI. There are more, like just some examples. So for example, in product development, we're using machine learning and AI as well, to design the features and models that our customers admire. For example, what we can use with machine learning there is to identify the control levers that have an effect on the performance of our vehicle functions. Just for explainability, it's not about using the model in production, it's about understanding basically the control levers. There are many other cases, of course. And in supply chain and logistics, it helps us to predict our demand more accurate and reduce the planning efforts. It's very important in these times, looking at the last years with the semiconductor shortage, for example, to manage these scenarios. Vehicle production, we've seen with the quality inspections, there's more like predictive maintenance, for example, in vehicle production. And then in sales and after sales, it helps us to improve like the interactions that we have with our customers. And even for our workforce, AI helps us to be more efficient. And what's important in a large enterprise is for like employees is like to find the right information. And of course, you've seen all those generative AI reg use cases here at the conference. This, of course, is also something that we are trying to leverage. To scale AI in those business processes, we believe that there's a strong platform so that the individual use case teams can actually focus on their use case and don't have to do all this setup work. And that's why my team is providing these platform services. And before we do this deep dive on machine learning AI development, I wanted to give you a very peak overview on the platform services that we have, how we look into scaling. So one thing we have is AI business services. It's basically a cluster on services that are not domain specific, but can be used in all the domains. So for example, there's an API on doing text translation, an API on extracting information from documents. And what's good with that is they don't need to reinvent the wheel. They can simply use the service, integrate in their processes, and all is good. And then there's more the custom machine learning AI part, like we've seen with the vehicle production. They need to build AI models. And for this, we provide the tools for like data scientists and business domain experts as well. And we dive deep on that. And then we have the management for unstructured data, like images and audio data. We need to record it, manage it, and provide labeling tools and labeling services to annotate the data. And then for those digital assistants, they benefit from a platform where they can develop those assistants and operate them in a safe way. And with MLOps, we provide the best practice solutions to industrialize the AI models that we have developed. We've seen in a demo that there will be more smooth integration between AI development and production. That is something that we are going to leverage in there as well. And then the last part, which is especially becoming more and more relevant now these days, is like governance for AI. So we need to have this overview on our AI use cases, right? We need to know where they are, what they use. And we have a central repositories for all the AI models to have like a safe, revision-proof storage for it and all the metadata associated with that. And we even have now risk assessment processes to assess the individual AI use cases. So that's like the overview on the portfolio, but today I wanted to deep dive on the machine learning development part, like the code-centric part for data scientists, machine learning engineers. And for us, like way back, it started all with specific purpose environments. So looking back like 7 years ago, we've seen like an increase on use cases that work with unstructured data, with images, with audio data, with texts. And what they mostly did is they took larger pre-existing models and did transfer learning to our data to solve those use cases. And what they needed is sufficient GPU performance, GPU memory in decent amounts. And that's why we ramped up this deep learning platform for them. And they could use Jupyter notebooks, their terminal in a containerized environment that we've run on premises in our data centers and managed this environment for them. And then there came those use cases that wanted to use more sensitive data. And there we saw the limits with the common platform approach, and we ramped up a new platform which provided the necessary level of security for them. And then there's, of course, many data scientists, machine learning engineers that work locally, do their experiments there, and many different other local solutions with other like software vendors. And the challenges that we had with this fragmented approach is, of course, is like the multitude of operational and governance overhead for us in the end. And for users as well, if they're working on different use cases or different aspects, they had to use different platforms. Yeah? We had real challenges to manage the compute demands, yeah? Because we need to plan ahead, we need to purchase hardware, ramp up things, we have to like exchange existing hardware and so on, really tough. And we had those peaks where users were unhappy, and we had those times where the hardware was not properly used, like on weekends, for example, so really hard to manage. And that's why we decided to overcome this fragmentation and challenges and come up with a solution, like a one-fits-all solution that would replace those platforms and motivate even the local users to switch on a central solution and bring all their workloads there. We coined the name for the solution Jupyter Managed because we wanted to make clear that there's a one-fits-all approach now, which should take in all the combined requirements from the different use cases. So starting with tools, we needed to provide all the tools that they need, and there will be a growing demand in that, of course. And everyone needs to be able to access their data. So may it be data in our group-wide data lake, in the Cloud Data Hub, or data in on-premise databases, or uploading local data. We need to supply that. Of course, the new solution needs to be elastic and scale with the demands. It was one of the major requirements, and have a low operations effort. From a security perspective, we had to bring in our like corporate standards to have like security incident event reporting in there, and integration with our identity and access management systems, malware scanning for the people that upload data, for example. And we needed to support, of course, different teams, up to different legal units, having people from the BMW bank on there, people from the automotive in there, and separate clearly their environments in a compliant way. And last but not least, we wanted to foster collaboration in the teams with sharing data and sharing code inside the tooling. And we looked at different alternatives, and finally we came to SageMaker Studio and said we want to use that solution. And because SageMaker Studio already fulfilled many of the requirements, which allowed us and my team to actually work on the integration. So we didn't have to build the platform from scratch. We could work on the integration. And I wanted just to provide you a glimpse on this provisioning and onboarding process for teams, how we do that at BMW now. So what we have is a BMW-specific service catalog for IT services. So a new data science team goes there and requests a new workspace. And they, for example, have to specify their cost center because we need to charge the costs internally to them, right? And then an automated process kicks off, and this automated process will create a new AWS account for them that is managed by us, and we provision all the infrastructure into that, like the SageMaker Studio domain, for example, our custom kernels that we need, the lifecycle configurations that we need, and some of the security features that we add on top. And then, once that's set up, all the users can enter a central portal and access their workspace, basically. And when they're in Studio, they can directly import data from our data lake. They can integrate with the on-premise database and basically create value directly. And they don't have to mess around with all the configuration and the setup and the security and all of that. We are taking care of that. So, as I said, SageMaker Studio allowed us to focus on this integration. And I just wanted to mention like a few features that we really value. But there's a lot more. For example, like choosing different instance sizes for the different workloads is very good for us because we have one platform for all the different cases. They can go using SageMaker training with distributed training jobs for larger workloads. We can bring in our custom kernels with like BMW-specific libraries to interact with our data lake, for example. And there's the option to schedule notebooks. We've seen that before in the demo. It's very important for some of our users. So all in all, looking at the solution now with SageMaker Studio is very good for us because we benefit from those new features, features like we've seen today, features that are added constantly. We also value that SageMaker Studio is building on open source components like we've seen today with VS Code, with Jupyter Lab, for example. That's very good for us. We really value that. So what's next for BMW Group with SageMaker Studio? So we will continue onboarding teams to the new solution. Not everyone is onboarded yet, so that's still ongoing. And what we are working on is integrating our MLOps solutions for AWS, which we already have for some years. So we already have a SageMaker-based master solution, and we are going to integrate it for a smoother experience. We, of course, would leverage the features for increased developer and data science productivity, like code generation. Many users look very ambitious to this faster startup times of notebooks, so this is really valued. And last but not least, of course, we would provide access to large language models and other foundation models inside our development environment. For example, for people being able to analyze texts, doing clustering, for example, with large language models. So with this, we see us well prepared, and I really appreciate the new studio release. And with that, I would invite you back on stage, Sumit and Giuseppe. So really, thank you for the demo and the release. I really appreciate that.
Thank you, Mark. Thank you for giving us insights into how you're using Studio at BMW. And You have been a great audience, by the way. Thank you. Thank you for coming today for this session.